Tell me when you're starting.
Okay, recording has started.
Hi, welcome to our CSE 412 project proposal, phase one. Um, Today we're going to be talking about our application, which we chose to be an a restaurant booking and ordering system. So the overview is that's going to be a ordering system where we can not only reserve tables, but also browse menus, place orders, food and beverages, and complete payments in one singular integrated platform. So it's like a one-stop shop for everything related to booking a table. And so there's a couple different entities when it comes to this application. We have a customer. Um, the customer has a couple different actions that they could do. They could create multiple reservations. Each customer has an ID called a customer ID, and they come with multiple details such as their name, number, and email. And the customer is also able to use the system to place orders, reserve tables, and also just make payments. Next, we have the ability to do reservations. This represents the customer's ability to request to book a table for a certain time. Each reservation comes with an ID and a time and a size for the party, and an optional special request area in case there's birthdays or something. A reservation also has the ability to be requested by only one customer at a time for a specific table, and it comes with a status that changes over time. Then we have tables. This is the location that people will be seated for at the restaurant, and each table has a unique ID that can be tied to a certain seating capacity and table number. And these tables are assigned to reservations based off of their availability and the size of the party. And a table can be reserved multiple times throughout the day, depending on the amount of time slots available for that table. And then finally, we have menu items, which is the items that the orders can be placed from. Order is going to be created by a customer when they select these menu items to be purchased. Each order comes with ID and the customer and their customer details. The order item represents a specific menu item included in the order. So we can also reference menu items and this belongs to a specific order. And finally, payment is what finalizes an order and it is able to track the success rate of this order. Finally, user interactions and system behavior. You have reservation management, which has to do everything with reserving a certain size party to a table. And then you also have menu browsing and ordering. This is the main action customers would usually take when they come to the restaurant. Got payment processing. This is the customer's ability to process their orders and also pay for their orders with appropriate payment methods that we decide. And then finally, we have the searching and information access mechanism where we're able to search for specific menu items by name for customers so they can also view their past reservations and their orders that they prefer. Now we're gonna hand it over to the ER diagram.
Okay, so as Meta mentioned earlier, second, we have a few entities here to go over in the ER diagram. So we have, if we start at the top, we have payment. The primary key of payment is going to be payment ID, and the attributes of that are going to be amount, method, status, and paid time. Then we can go over to, I think it makes more sense to go over to customer too. So customer has primary key of customer ID. There, a customer can place multiple orders. If we go over to orders, primary key is order ID. And then we have orders can have one order item, which has a primary key of order ID. And then the order item can reference many menu items, which has the primary key of menu item ID. Um, Kind of working back from customer, we have the entity, which has a primary key of reservation ID. The reservation is requested by the customer. And then the table, which is the entity towards the bottom left, is the last entity, which is reserved from the reservation. And that has a primary key of table ID. So if we look at this entity relation diagram, we can see that payment looks like there's one to many for orders to payments. There's one to many from order item to menu items. There's one to many for reservation to customer, and then there's one to many for tables to reservations. So this is what we're going to use to create our Postgres SQL database and help the app have the correct relations for each data entry.
Awesome. Thank you, Jacob. And then onto the implementation plan. So our team will implement a web application of this three-tier architecture using different types of technologies. One of them is using React for the front end for the customers and the staff. Then we'll use a REST API backend using Python and Fast API. And finally, a PostgreSQL as a central DBMS. Following the ER diagram, the PostgreSQL tables will directly mirror the core entities such as customer, order, payment, order item, menu item, reservation, and table with the foreign keys kind of enforcing this relationship as shown in the diagram. Then, functionally, the app works where a user creates an account and login information, browses available menu items, and then places an order. The backend creates the order row along with its order item row in a single transaction, calculates the totals, and then records a payment when the user checks out. For dinner reservations, a user submits a reservation request detailing the time, party size, special request, and then the backend assigns a table based on capacity and availability rules. Finally, the reservation updates with its status when confirmed, canceled, or changed. Staff views can be simple admin pages on the same web app to update menu availability, view active orders, and manage reservations. In this way, this keeps the PostgreSQL as a single source of truth and kind of like customizability, and the API the only way that the UI reads or writes data. All right, guys, this is our full implementation plan and project requirements. I think that's all.